Welcome to a tropical world. My lecture consists of 8 lectures. The first of the part of the lecture, I focus on the essential of the geometry, a tropical geometry. And the last part of the lecture, second part of the lecture, I focus on the application, this tropical geometry, to the other field of mathematics, differential geometry, and ultimately statistical machine learning. Okay, I concisely introduce my curriculum. The first lecture is the tropical number system. Addition and multiplication is quite familiar. However, in a tropical number system, there are tropical sum and there is tropical multiplication. If two number is given, tropical sum is defined maximum between of two numbers, or it depends on the other. One others defines minimum of AB. And the multiplication is defined just addition, as we know. The problem is that the operation is well defined. In first lecture, I deal with this well-definedness of this system and additional property. Abstract, not the structure, abstract structure, algebraic structure of this system, so-called tropical number system. In abstract algebraically, that is a hyperfield. I will deal with anyway the abstract structure of the tropical number system. And in the second, consider a quadratic function that is easy to plot. However, in a tropical system, as I said, the multiplication and addition will be changed, the tropical sum and tropical multiplication. The second lecture, I concentrate on tropical curve. All sum and multiplication is replaced by tropical sum and multiplication. And it extends into the, that is just real line, and extended to plane, so-called T2, from T to T2. If we, in particular, in a tropical plane, if the image is plotted by plane shape, but it projected onto XY plane, the graph shape is like something. So one example of the projection image of plane into the XY plane. It is geometrically like a branch of the tree or a cell space. Anyway, the important part of this graph count the number of face, number of edge, and the number of vertex. And the second lecture, we will do a dualization of this tropical curve. If we know the Poincare duality, number of when we consider a dual image of the curve, a polyhedron, the number of face is the number of vertices, and edge is still same, and the number of vertex is flipped by number of face. That is Poincare duality. In a tropical curve, we can consider a dualization of, that is the dualization of tropical curve. The question, what is the geometrical meaning of this dualization of tropical curve? The third lecture, I will deal with this in detail. The next, I will deal with phylogenetic tree. That is, describe the evolution of the time, age, species. In this part, I will concentrate on p-adic valuation. That is important. One way to compute the distance between species. Of course, the phylogenetic tree, the shape of phylogenetic tree is deeply related to a tropical geometry. I will deal with the later part. And this part is an application. First, so this is a first step to approach the tropical P-Wasserstein metric, tropical deep learning. The first part is to understand the differential geometry part of intrinsic distance. On the fifth lecture, I will introduce the concept of the differential geometry in detail. And sixth lecture, I will mention a statistic distance. As I know, Kullback-Leibler divergence in fact is not a distance, and Wasserstein distance. The concept is quite abstract, but later, the last lecture, I will introduce what is the geometrical meaning with a tropical torus. The tropical torus are MR1. Precisely, the name is tropical projective torus. If we understand a tropical projective torus, that is related to a phylogenetic tree, the relation between phylogenetic tree and tropical projective torus. Even though I will delve onto the relation, deeply understand the relation between phylogenetic tree and tropical projective torus, but I introduce the relation between two objects. And the last part, tropical P versus time metric, that is related to deep learning system. And in this part, as I said, the geometrical meaning of Wasserstein distance.